Hello everyone, today we're going to look at exponent rules. The first rule is called the product rule, and it's when I'm multiplying the same base, the bases have to be the same, of something like x to the n times x to the m. So what I'm going to do is just write it out by definition. So x to the n is x times x times x, n times, and x to the m is m times. So I have n x's, and then I have m x's, so I have n plus m total x's. And by definition of exponents, that is x to the n plus m. So if you ever can't remember these rules, go back to the definition, what does x to the n mean, and you can always figure it out that way. The next one is the quotient rule. So I have x to the n divided by x to the m. And again, I'm going to have n x's on top and m x's on the bottom. So a bunch of these x's are going to cancel out. And what it equals depends on which number is bigger, n or m. So if I have something like x to the 7th over x cubed, I have 7 x's on the top. Now it's supposed to be cubed. And I have 3 x's on the bottom. So one of my x's cancels, another of my x's cancel, and another of my x's cancel. So if the n, the numerator one, is bigger, then I still have x's left on top, and how many I have is 7 minus 3. Now if I have a bigger number on the bottom, then I'm going to have something that looks like this. I have 5 x's on top. I have 8 x's on the bottom. And then when I go to cancel them, I still have x's on the bottom. How many I have on the bottom is still a difference, but this time it's the numerator, it's the denominator minus the numerator, whereas before it was the numerator minus the denominator. So in either case, I'm going to be taking the bigger number minus the smaller number, and then if the bigger number is on top, my answer is still in the numerator, and if my bigger number is on the bottom, that's where my answer is going to be. So it's going to look something like this. If n is bigger, then it's x to the n minus m, but if m is bigger, then it's 1 over x to the m minus n. If they're the same, then it's just x to the, say, n minus n, which is x to the 0, which is another rule that we're going to look over in a second. The zero power rule. Any number, whether it's a variable or an integer or a fraction or a decimal, any number to the 0 is 1. Okay? So no matter what it is, if I raise it to the 0, it's 1. The last rule is what we call power to a power. So if I have x to a power, so x to the n, and then I raise that to a power, again, I can go through what the definition is, but hopefully you can see that I'm going to multiply them together, because x to the n, and then I have that m times, I'm taking by the product rule, I'm going to be adding it, so n plus n plus n plus n, m times, is by definition n times m. Okay, so if I'm multiplying, I add the exponents. If I'm dividing, I subtract the exponents. And if I'm raising it to a power, I multiply them. So we're going to use these rules in a bunch of examples. So simplify using the rules of exponents. So my first one, x to the 5th times x cubed, that's multiplication, which means I'm going to add them. So 5 plus 3 is 8. For my next one, I have x cubed over x to the 7th. The denominator is bigger, so my answer is going to be 1 over x to the, and then subtract. 7 minus 3 is 4. So I have 1 over x to the 4th. The next one, I have x cubed to a power. So that means I am going to multiply it together. And that's going to give me x to the 6th. The next one is 3x to the 0. So be careful here. You have to remember order of operations. I am raising x to the 0 first, and that's a 1. And then I'm multiplying by 3. So 3 times 1 is 3. I have a lot of people who will tell me that's 1, but the 3 is not being raised to the 0. Okay, so it's only the x that's being raised to the 0. So again, x to the 0 is 1. 1 times 3 is 3. For the next one, I have x squared y cubed, all cubed. So now we have to remember that multiplication is commutative. So if I wanted to do this out by definition, it would be x squared y cubed times x squared y cubed times x squared y cubed. But I can multiply in any order, so I'm going to put all my x's together. X to the 2 plus 2 plus 2 is x to the 6th. And then I'm going to put my y's together. Y cubed times y cubed times y cubed is y to the 9th. So I can multiply, I can kind of distribute the exponent here. I don't like to say that though, because distributing is really when you have addition, which you can't do here. So as long as I have multiplication or division inside being raised to a power, I can raise each one individually. So this is really x squared cubed times y cubed cubed, which is, again, you multiply 3 times 2 and 3 times 3 to get our 6 and 9. And then the last one on this page, x to the 8th over x cubed. Again, it's division, so I'm going to be subtracting. The larger one is on top. So it is raised, so it is x to the 8 minus 3, which is to the 5th. A couple more. I have something being raised to the 0, no matter what that thing is. I don't care how many factors, how many terms it is. If it's all being raised to the 0, it's 1. The next one, I can do a couple of ways. I can either distribute the 2 to all 4 of my factors, or I can clean it up first. So really going with order of operations, I'm going to start with parentheses. So x squared over x to the 4th. The 4 in the denominator is bigger, and 4 minus 2 is 2. So that goes down in the denominator. And then with the y's, my numerator's exponent's bigger, so it's going to go in the numerator, and 3 minus 2 is 1. So I'm going to take that whole thing and square it. So I have y squared, and then x squared squared is x to the 2 times 2, which is 4. So y squared over x to the 4th. For the last one, it's multiplication. Again, I can multiply in any order. So I'm going to start with my coefficients. 3 times 4 is 12. Then I'm going to move on, whoops. Let's circle back on that. And move on to my x's, that's a little better. X squared times x to the 7th. I add them, and I get 9. And then y to the 4th, y squared. Again, I add them, and I get 6. So 12x to the 9th, y to the 6th. Okay. And then my last 3. Again, I've got some dividing here, so I'm going to do it term by term. I'm going to start with my coefficients. 4 divided by 12. I'm left with a 3 when I simplify it. That 3 is in the denominator, right? 12 is bigger than 4, so it's in the denominator. Next is the x's. X squared over x to the 5th over x squared. The numerator is larger, so I know my x is going to be in the numerator. 5 minus 2 is 3. Next, I look at my y's. The denominator's exponent's bigger, so I know my answer is going to be in the denominator. 8 minus 3 is 5. And then lastly, my z's. Z to the 8th over z to the 8th. I can think of that two different ways. It's something divided by itself, so I know that's 1. Or, again, that's z to the 8 minus 8, which is z to the 0, which is 1, which means I don't need it in my answer. So I just have x cubed over 3y to the 5th. In my next one, again, I have something raised to the 4th, so I'm going to raise each one individually to the 4th. So 3 to the 4th is 81. X squared to the 4th, I'm going to multiply my exponents, and they get 8. And then y cubed to the 4th, again, I'm going to multiply my exponents and get 12. So 81 x to the 8th, y to the 12th. For my last one, I have 3 squared times 3 to the 4th. So rules of exponents, it doesn't matter that my base is a number, right? The rules of exponents stay the same. I'm going to add my exponents. The base does not change. It's not 9 to a power. It's still 3. My base never changed before, so it's not going to change now. Okay, so it's just 3 to the 6th. Whether you want to plug that into your calculator and come up with the integer answer, doesn't matter. I'm going to leave it as 3 to the 6th so that it's still in exponent form. Okay, so make sure that you play around with the exponents. Make sure you can remember what they all are. If you continue with another math class, you're always going to need to know the rules of exponents. I'm always telling my students in other classes, you guys learned this now. You have to remember it. You're going to be using it a lot. Okay, so try it out. Make sure you read through the book and let me know if you have any questions. Thanks.